Okay, so this is lesson 8.1, and we're starting a new chapter on estimating proportion with confidence. So confidence intervals is the idea here. I think the next thing that's coming is going to be tests, but let's just do the basics. We're talking about proportions and confidence intervals. So let's learn what those are. We'll kind of step into this a little bit slowly, and we'll get there. Whoops. So that should be 8.1a right there. There we go. Okay, what's a point estimator? We've talked about a point estimator before. It's a statistic like p hat or x bar that's making an estimate about the population parameter like mu or p. So the value of that statistic is called the point estimate. So the point estimator is giving us a point estimate, so to speak. So identify the point estimator you would use to estimate the parameter of each of the following settings and calculate the value of the point estimate. Quality control inspectors want to estimate the mean lifetime mu, like the mean, of the AA batteries produced each hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. Seems like Tesla needs to do this under cold conditions. I heard about a lot of Tesla cars that the batteries weren't charging correctly. Here are the lifetime and hours of the batteries from one such sample. Okay, so here's all the data. That's the one sample of 50 batteries that they took from a large population of batteries. So what is the point estimator we're going to use? Says what is the point estimator you use? Well, it'd be X bar. It'd be the mean of the sample. And so you would take the time to type in all 50 data pieces. I think I typed them in correctly, but it was challenging there. And then you would do one variable stats. You remember how to do that? You go to menu 611, and then you choose one list, and you choose the list I called my batteries, and it'll calculate it for you. And here's what I got. The mean is 16.718 or something like that. Let's see what they got. 16.178. So I think I typed them in slightly wrong. Or maybe they did. I don't know. I mean, I typed a lot of those guys in. Had the right number of them, but we'll see. But that's the idea. You're just finding the X bar. That's the point estimator. So the point estimate is 16.178. We're going to use that. That's our estimate for the population mean of the batteries. So in hours, of course, we're using the context of the problem. What proportion P of U.S. adults would classify themselves as vegan or vegetarian? That's interesting. Pew Research Center surveyed 1,473 randomly selected U.S. adults. Of these, 124 said they were vegan or vegetarian. So you want to get your calculator out, and you would do, I guess, 124 divided by 1,473. We would call that P hat, right? And so we get a point estimate of 0.084. That's our P value there, proportion. So P hat is our estimator, and our point estimate is 0.084. The quality control inspectors in Part A want to investigate the variable in battery lifetimes by estimating the population standard deviation. So we're going to use the sample standard deviation to do that. If you scroll up here on the calculator, at least when I typed it in, I had a sample standard deviation of 0.664. See what they got? 0.664. So I evidently, maybe I didn't type it in that badly. But that's our point estimate. That's our sample standard deviation, which we're going to use. Our point estimate is 0.664 hours for the population standard deviation. That's our estimate we're going to use. When the estimate of a parameter is reported in an interval of values, it's called an interval estimate or a confidence interval. That's kind of what we're getting at here, this idea of a confidence interval. So it gives all the plausible values of the parameter. So we're trying to estimate the parameter of the population based on the sample data. Plausible is not quite the same thing as possible. Plausible means that, if we have two values that's in between, we think the true value of the mean of whatever we're doing is going to be in between those plausible values there. There wouldn't be surprised if it came between them. So they're constructed so we know how much confidence we should have in the interval. And the most common one by far, I think this is really popular, is the 95% confidence interval. We'll get more into that later. But that confidence level, C, is the percentage of all the possible samples that will capture the true parameter value. So we're hoping that we're 95% sure that the lower bound and upper bound will capture or the parameter will be inside of those two values. We'll learn how to interpret those later. Sorry. So this is the interpreting a confidence interval. I thought this was the next section, but I think we're not quite there yet. So interpret a C percentage confidence interval for an unknown parameter. Say we are 95% confident or C% confident that the interval from blank to blank captures the true parameter or mean or whatever it is we're studying of the population. So that's the kind of the script that we're going to use for interpreting a confidence interval. Some people say based on the sample data. Make sure you're describing the population though. A confidence interval describes the population parameter, not the statistic. To create an interval of plausible values, we need two components, a point estimate to use as the midpoint and a margin of error to account for sampling variability. So it kind of looks like that. I like that picture there where there's a point estimate in the middle. We're going margin of error at each side. It might be a few percentage points on each side. It might look something like that. 0.65 plus or minus 0.037. We're 95% confident the interval proportion of all U.S. adults who would admit to experiencing some financial difficulty would be between 61.3% and 68.7% there. So that's the proportion. That's our estimate that the true proportion of all U.S. adults who would experience some financial difficulty would be between those two lower bounds and upper bounds. It's called the margin of error is an estimate to describe how far at most we expect to vary from the true population. It's in both directions, right? So we think it'll be less than that. The true proportion will be inside of there. So 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election was held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population proportion who favor candidate A is 0.48 to 0.54. Interpret the confidence interval. So I'm 95% confident, based on the sample, that the true proportion of folks who would vote for candidate A is between 48% and 54%. Let's see what they said. Captures the true proportion of all registered voters who vote for candidate this election. It's pretty good. What is the point estimate that was used to create this interval? What is the margin of error? So point estimate would be, so let's take those two numbers, 0.48 plus, 0.48 plus 0.54 and divide that by 2. So 0.51. So 0.51 is in the middle. I average those two numbers, add them up, divide by 2. So 51% is our point estimate there for P. And then it looks like that's 3 units away. I mean, you could do 0.54 minus 0.51 just to see you're at 3 percentage points away in either direction there. So that's going to be the margin of error is 3%. That's always true for political polls, by the way. Based on this poll, it's always 3%. Political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. Well, he's a little bit off. I mean, it's definitely possible, but if you think the true proportion is going to be between 48 and 54%, well, Sometimes that's above 50%, which means favoring A. Sometimes it's below, so it's not always there. So because the whole interval is not bigger than 50%, I don't think we can say that. Let's see what the result is here. So that's the margin of error. Because there are plausible values of P less than or equal to 50%, I don't think we have convincing evidence of that. So I would agree with that statement. Try one more problem. You're done with today's lesson, but let's just try an problem on your own. Maybe you can do this one. And I would encourage you to consider doing one variable stats for this rather than just doing these separately. Might be less work for you. So if I were you, I would just start by going, okay, let's do one variable stats on this. This is sleep, so I'm going to call this one sleep. 4, 5, 5.5, 6, 6, 7, 7.5, 8, and 10. Okay, make sure you get out of that last cell. I like to add a calculator page at this point, and then do one variable stats, so menu 611, one list, sleep. And so there's my answers to some of those questions I'll need in a minute. So counselor at a large high school wants to estimate the mean amount of sleep, mu, that the students got the previous night. She selects a random sample of 10 students, asked them to record the number of hours they slept that night. Here are the results. Wow, one student got 10 hours. It's amazing. One student got 4 hours. Okay, that makes sense sometimes. Okay, so the X bar would be 6.6. That's our point estimator that we're going to, so our point estimate is 6.6 here. 6.6, I should say hours. We're always talking context here. But X bar is our point estimator and 6.6 hours is our point estimate. It's recommended that the high school students get 8 hours or more of sleep each night. You probably know that. The counselor wants to estimate the proportion of all students at the Stars High School got recommended amount of sleep. So this would be, let's see. So how many of those got at least 8? So 2 out of 10, 2 divided by 10. I guess I could use a calculator for that. So 20% it looks like. Let's see, 20% is our p hat. And so 20% folks, 20% is our point estimate as well. Part C, counselor wants to investigate the variability in sleep times by estimating the population standard deviation. So I think I would scroll back up to this, and you can see right there at the top, the sample standard deviation is 1.6964. So that's going to be our point estimate for the population standard deviation, sigma. It would be 1.696 hours in this case, would be the standard deviation. Okay, that is your lesson for today.